Hello students, I again welcome you in our physical chemistry class. I think that you are now familiar with my name, that is Miss Akanksha Sangdev Gurule, and I hope that whatever I have taught you in the previous three lectures, that all you have studied well and you have understood each and everything from that lecture. So in the today's lecture, we are going to discuss some numericals based on the standard enthalpy of formation. So our numerical is enthalpy of formation of C2H5OH, CO2 and H2O are minus 277, minus 393.5 and minus 285.8 kilojoules per mole respectively. Calculate enthalpy change for the reaction. C2H5OH reacts with 3 moles of O2 to give 2 moles of CO2 plus 3 moles of H2O. So now we will write the given things. So what are the given things in the given problem? Enthalpies of formation of C2H5OH, CO2 and H2O are given to us. So now we know that enthalpy of formation is denoted by delta HF naught, and delta HF naught for C2H5OH is equal to minus 277 kilojoules per mole. Next is delta HF naught for CO2 is equal to minus 393.5 kilojoules per mole. Next is delta HF naught for H2O is equal to minus 285.8 kilojoules per mole. So now we know that delta H naught for reaction is equal to summation of delta HF naught of products minus summation of delta HF naught of reactant. So now putting the values, we have seen in the previous lecture that we have to consider the stoichiometric coefficient of each and every terms. So the stoichiometric coefficients of product is 2 in 2 moles of CO2 and 3 moles of H2O. So first 2 into delta HF naught of CO2 plus 3 into delta HF naught of H2O minus reactant 1 into delta HF naught of C2H5OH plus 3 into delta HF naught of O2. Okay. So now putting the values. 2 into delta HF naught of CO2 is minus 393.5. Okay. Plus 3 into delta HF naught of H2O is given as minus 285.8. So this was for the product terms. Minus 1 into delta HF naught of C2H5OH is minus 277. So now you must be thinking that delta HF naught of O2 is not given. That means it is taken as 0. So in the previous lecture we have studied that standard enthalpy of formation of any pure liquid is taken as 0. That means 3 into 0 will be 0. So we have not written that 0. Okay. So now 2 into minus 393.5 is equal to minus 787 plus 3 into minus 285.8 is equal to minus 857.4 minus 277. Minus 787, this plus minus becomes minus 857.4. This minus minus becomes plus. We know that minus minus is equal to plus and the sign of the bigger number. So this addition comes to be 1644.4 plus 277. Plus minus is minus and sign of the bigger number, that is minus. So this subtraction comes as a 1367.4. The unit will be kilojoule per mole. So delta H naught for the reaction is equal to minus 367.4 kilojoules per mole. So our numerical is calculate delta H naught for the reaction. Reaction is carbon dioxide reacts with hydrogen to give carbon monoxide and water as a product. Given that delta HF naught for CO2 for CO and H2O are minus 393.5, minus 111.3 and minus 241.8 kilojoule per mole respectively. So always remember, whenever you solve any numerical, you have to write the given things. So what are the given things here? Delta HF naught for CO2 is equal to minus 393.5 kilojoule per mole. Okay. Delta HF naught for carbon monoxide is equal to minus 111.3 kilojoule per mole. Okay. And delta HF naught for H2O is equal to minus 241.8 kilojoule per mole respectively. Okay, so we know the formula that delta H naught for the reaction is equal to summation of delta HF naught of product minus delta HF naught for the reactant. Now putting the value, the stoichiometric coefficient of carbon monoxide is 1. 1 into delta HF naught of carbon monoxide plus stoichiometric coefficient of H2O is 1. 1 into delta HF naught of H2O minus 1 into delta HF naught of CO2 plus 1 into delta HF naught of H2. So you might be thinking that delta HF naught of H2 is not given, but you have to remember that enthalpy of formation of any pure element is taken as 0. So that means delta HF naught of H2 is 0. So now putting the value 1 into 111.3, that means minus 111.3 plus this 1 into minus 241.8 minus 241.8 minus 1 into delta HF naught of CO2 is equal to minus 393.5. That means minus 393.5 and this 0. Okay. So now minus 111.3. This plus minus becomes minus 241.8. This minus minus will become plus 393.5. Minus minus is equal to plus and sign of the bigger number, it is minus, and it is equal to 353.1 plus 393.5. Plus minus is minus, that is we have to do subtraction, and sign of the bigger number, that is plus, and this subtraction is equal to 40.4. The unit will be kilojoule per mole. That means delta H naught for the reaction is equal to plus 40.4 kilojoule per mole. Next numerical is enthalpies of formation of CO2 in gaseous state and H2O in liquid state under standard conditions are minus 394.65 kilojoule per mole and minus 285.84 kilojoule per mole. If the standard enthalpy of combustion of acetaldehyde, that is CH3CHO, be minus 1167.62 kilojoule per mole. Find its enthalpy of formation. So first what we will do, we will write all the given things in the question. So given things are delta HF naught for the CO2 is equal to minus 394.65 kilojoule per mole. Okay. Next, delta HF naught for the H2O is equal to minus 285.84 kilojoule per mole. Okay. Next, the standard enthalpy of combustion, that is delta HC naught of acetaldehyde, that means CH3CHO, is equal to minus 1167.62 0.62 kilojoule per mole. Okay. So now what we have to find? We have to find delta H naught, that means enthalpy of formation of CH3CHO. Okay. So first of all, what we have to write? We have to write the reaction for combustion of acetaldehyde. Okay. So when there is a combustion, there is an addition of oxygen. Okay. To give. So when there is a combustion of acetaldehyde, it will give carbon dioxide plus H2. Okay. So you might be thinking that why I have directly written carbon dioxide and H2O? Because in our question the carbon dioxide and H2 are given to us. That means that must be our product terms. Okay. So here we have to balance the chemical reaction. Okay. So how many carbons are there at the reactant side? 1 and 1, that is 2. So here only one carbon dioxide is formed, that we have written. So it must be 2 moles of CO2. Okay. How many hydrogens are there? 3 plus 1, that is 4. So here 2. That means there must be 2 moles of H2. Is it okay? Now we have to balance the oxygen. So how many oxygens are there at the reactant side? This 1 plus 2, that is equal to 3. And now at the product side, this 2 into 2 is 4 plus 2, 6. So here there are 6 oxygen and here there is 3. That means what we have to do? We have to take here 6 oxygen. So how we can take it? So now 5 by 2 moles of oxygen. Okay. So now here there are 5 plus 1, 6. Here 4 plus 1, 4 plus 2, 6. Is it clear? So delta H for this reaction is equal to minus 1167.62 kilojoule per mole. Okay. So now delta H naught for any reaction is equal to summation of delta HF naught of product minus summation of delta HF naught of reactant. Okay. So now let delta H naught of CH3CHO equal to X. Okay. So now putting the values. So delta H naught for this reaction is minus 1167.62. Okay. So now 2 into delta HF naught of CO2 plus 2 into delta HF naught of H2. Okay. Minus 1 into delta HF naught of CH3CHO plus 5 by 2 into delta HF naught of O2. So we know that standard enthalpy of formation of pure element is taken as 0. So now putting the values, 2 into minus 394.65 plus 2 into minus 285.84 minus 1 into x plus 5 by 2 into 0. Okay. So this multiplication comes as minus 789.3 plus minus 571.68. Okay, minus x. This minus 1167.62 as it is. So this minus 789.3, this plus minus becomes minus 571.68 minus x. So this minus minus is plus, sign of the bigger number. So this addition is equal to 1360.98. This minus x as it is. This 1167.62. So now we will transfer this minus x to the right hand side. It will become plus x. Minus 1360.98. This minus 1167.62 we will transfer to this side. It will become plus. So now this plus minus becomes minus, sign of the bigger number. So this subtraction is equal to minus 193.36 kilojoule per mole. That means delta HF naught for acetaldehyde, that is CH3CHO, is equal to minus 193.36 kilojoule per mole. All the numericals which I have discussed in this lecture, you have to practice them at home, as well as you have to solve some more numericals of this type. Okay, so thank you.